I'm Candice and Moraga, and I'm here with another diabolical laboratory experiment. And this one is going to be on a little toy popper. Cute and pink, of course. This is a little bit hard to show you what I'm doing, so I'm probably going to do this in two parts. But let me just explain what this popper is, because I didn't even know what it was at first. I was like, what am I even looking for? So I had to Google poppers just to see what it is. I guess I didn't have, crazy toys like this growing up, because it would have driven my parents crazy. So basically what I've discovered is what you're supposed to do with this thing is it's normally in a stable position like this, as you can see, and it's made of a plastic that's flexible, but it's still pretty stiff. And what you do is you invert it like so. In this way you're actually sort of converting some of your own energy and storing it within this plastic popper, and now that it's in an unstable position, it wants to revert back to its regular position. So when I put it on a hard surface, it will bounce back up, and in doing so it applies a force, pushes like that, it applies a force to the hard surface and bounces straight up in the air. Now it says to do it on a table. I don't have a table, but I have a kitchen countertop, and I've discovered after testing out to see if I even knew what I was doing with this thing, it has repeatedly every single time hit the ceiling. So one of the things I need to do is to calculate the height to the best of my ability, so I don't think that's going to work off of the countertop. So what I'm going to be doing is doing it on the floor in here. I do have a little piece of floor in my kitchen that is tiled and therefore hard, and I've tested out. I can sort of estimate the height just standing up and waiting for it to pop, and I'm just going to mark on the wall with some pencil. Now I'll just erase the pencil marks afterwards, and so I can just measure them like that. I'm going to measure 10 times the height, and then I'm going to utilize my stopwatch here, my stopwatch, to do another 10 trials where I take the measurements of how long it took to reach the maximum height. Then I'll take the averages of these, and I can calculate an initial velocity and answer a bunch of questions on that and do a little lab report. There is a beginning part of this lab, but all I'm supposed to do is to examine the path of a roller coaster on my laptop, which is not too exciting, but luckily I've been on enough roller coasters in my life. Disneyland, Disney World, Canada's Wonderland, Darien Lake, Great Escape. I think I've been a couple places in Canada. Oh, of course, Dallas, Six Flags. Okay, so I've been on enough roller coasters that, I know enough about kinetic and potential energy that I think I can answer those questions just looking at that diagram like I'm supposed to. And I'm going to go ahead and show you some popper action, because that's sort of the cool, fun part, and it's better than just explaining. But so now you're not going to get to see my awesome face, so you're going to get to watch the little pink popper though. So here I am placing a pink popper on the floor, and I'm going to release it and try and figure out a height measurement and mark it on the wall. I already did one to make sure that it works well, but I wasn't doing it holding a camera, so I'm going to have to probably do them without. Well, okay, so it's sort of hard to ascertain it while the height while watching the popper and holding a camera. So I'm just going to go ahead and film the popper for you, and then I'll do all my measurements without holding a camera, because that's just too difficult, too many things at once. Doing this all one-handed and all that. See, very difficult. I can't really grab a pencil at the same time. Okay. Okay, well, you see the action going on. I tried one, and I put a little pencil mark on the wall, which for some reason, oh, there it is. So I'm going to measure with my tape measure here how tall it is in meters. See, I'm living out of a suitcase there. Okay, so I hope that explains well the lab, and I'm going to get back to work here. Peace.